we focus on blue ocean opportunities in the assistive technology, parking controls, and perimeter security markets. Let me define the term that I just used, blue oceans. The blue ocean strategy is a Harvard Business School study that compares the impacts of a gray ocean versus a blue ocean on your business strategies. Now, a gray ocean is very simply a polluted ocean. There's a lot of competitors, which means you're spending a tremendous amount of money on sales and marketing. And your profit margins are relatively low. And a lot of businesses fail and drown in the gray ocean. A blue ocean, conversely, is a nice, clean, cool ocean. It's so much nicer to swim in. The blue ocean has minimal competition, which means you can command better profit margins for your business, which allows you to grow your business, pay your employees a living wage, and give back to your community. Now, I've been in the RFID business, radio frequency identification business, for over 20 years. I founded and grown 2 RFID companies that are still in existence today. One of those companies is Applied Wireless Identifications Group, and the other one is Transponder and Reader Engineered Systems. While we focus primarily on automated vehicle identification and asset monitoring, I came across an unusual application at a facility called the Boston Home. The Boston Home is an amazing assistive care facility. At the time, they had 85 residents, all of whom suffered from the most severe cases of multiple sclerosis and ALS, and had lost almost total use of their limbs and their extremities. They were living in wheelchairs, much like this gentleman over here. Spending most of their waking life in wheelchairs presented a lot of mobility issues. And the issue that we were called in to solve involved elevators. The residents of the Boston Home would maneuver their chairs down the hallway into the elevator vestibule, and they'd sit there and they'd wait for a staff member to come by and press the call button for them. As you can imagine, with 85 residents in a full care facility, the staff was thin, busy, and always running. So they would press the elevator call button for the resident and they'd be off. The resident would then wait for the elevator to come. They'd maneuver their chair onto the elevator and whoops, more buttons to push. So they would sit on the elevator until someone called it from another floor, and that's where they were going. In a minute, I'm going to show you the technology that we used to solve that mobility problem. I do have to tell you a little more about the Boston Home, though. I was amazed by the spirit of these people, and I was taken aback. They were so profusely thankful for the installation of this system that afforded them more freedom of movement and mobility. I was brought to tears more than once talking to some of these residents. It was truly heartwarming to me to be able to make a difference in somebody's life. For so many years, doing automated vehicle identification and asset monitoring, you didn't get that many thank yous. The residents of the Boston Home were maneuvering their wheelchairs up close to me and just thanking me. It was incredible. It was a very heartwarming moment for me. I've just survived a year-long battle with cancer. All that time in the hospital and healing afforded me an awful lot of time to think about what I wanted to do with the rest of my life and the future of my business. And giving back is one of the things that I'm committed to doing. Let's talk for a moment about the technology that we use to solve these problems. Once again, there are 3 basic components in this RFID system. The first is the reader. It's a UHF long-range reader. This particular reader that I use is the UPass Reach from NEDAP. The reason I choose this reader is because of its superior manufacturing, its small compact size, and its dependability along with its affordability. The second major component is the tag. This is a heavy-duty metal mount tag. So this tag is designed to be mounted on any type of a surface, including the metal frame of a wheelchair. The third component that figures very prominently in this equation is the modular access panel from CANSEC. The map panel is where all the logic is stored. Now, very important points here. All of these products have all the regulatory specifications that would be required. They're UL listed, they're CE certified, and they're FCC Part 15 compliant. FCC Part 15 is important. The reason it's so important is because it dictates that RFID products in this frequency will not emit any harmful interference to other devices, especially medical devices. This reader operates at 902 to 928 megahertz. And if you care enough to look it up, you'll find that that is the ISM band. ISM stands for Industrial, Scientific, and Medical. This frequency will not interfere with medical devices, and that's a very important factor. Let me go through the operation of the product in a little more detail with you. I'll try not to bore you with a bunch of tech talk. I'll keep this simple. The RFID reader emits a field of RF. It bathes the air in front of it in RF. When this tag comes into range of the RF signal, it absorbs the signal, it accelerates the signal, and when it reaches what's called excite frequency, my favorite piece of terminology in the RFID business, by the way, when it reaches excite frequency, it transmits its encoded information to the reader. The reader then transmits that information to the modular access panel. I'll be calling it the MAP. The modular access panel is manufactured by CANSEC Systems. The modular access panel is where all the decisions are made and all the logic is stored. So the typical chain of data is this. We've got this tag encoded with a facility code and an ID number that is unique to this tag. The reader is currently reading that facility code and that ID number, transmitting it to the MAP panel. The MAP panel then goes to its database and says, oh, that's Doug Cram in his wheelchair. And he's authorized to call this elevator 24/7. Or perhaps they're enforcing quiet hours and I'm only allowed to call the elevator from 8 a.m. until midnight. This would also work the same way at a door. For example, if I'm exiting, wheeling my chair out into the garden, the MAP panel would know that I am or am not allowed in and out of that door at that time of day. And it will either grant access or deny access. Now, a system administrator has access to the software that we use to program the MAP. From that software, they can pull a report that will show them who's entered, who's exited, who's called an elevator, what time they did it. And if I was trying to get into the liquor cabinet after hours, it would say that I was denied entry. So it's a very smart system. Those are the three primary components. The other components that we connect to is door opening devices, door locks like a magnetic lock or an electric strike, for example, or the elevator relay panel. I'm not going to go into all of those devices today. That's a whole nother video. Now you ask, where does this tag get mounted? Well, that's a really good question. Where does the tag get mounted? First and foremost, I want to point out that this tag and this frequency is susceptible to body blocking. And I'm going to demonstrate to you what I mean right now. So you can tell by the reaction of that reader that it's reading that tag like crazy. That's all I need to do to body block that tag signal right there. Once again, it's reading, it stops reading. Body blocking is an important concept because the human body is made mostly of water. So we have to be careful not to put the tag in a place where parts of the human body will get between it and the reader, or it's not going to work real well. So let's look at where we would mount the tag. On a wheelchair, such as this one, the temptation would be to mount it up on the side of the armrest because that presents to the reader quite nicely. But we don't want to mount it there. And the simple reason is because whoever's in that chair could lower their arm over the side of the chair and it would body block the tag. So instead, we're going to mount it down on the frame of the chair. Because remember, I said this is a metal mount tag. Now, anybody that knows much about RFID knows that RFID and metal typically do not get along together. However, this tag is metal compensated. It's designed to be mounted on a metal surface. Let's talk about how we would mount a tag on a gurney. Here we have a traditional hospital gurney with someone pushing from the back of the gurney, which is very typical operation of it. So the purpose is that when this gurney gets within range of the reader, either a door or a pair of doors is going to fly open and allow that staff member to continue pushing the gurney without having to stop and press egress or ingress buttons. It will open automatically, saving them a tremendous amount of time. Now, this gurney could just as well be a crash cart. Any type of a cart or a gurney that you need to get through some doors very quickly and you don't need to have 3 people involved in the operation, this system is really applicable for. So we would mount the tag on this gurney towards the front of the gurney. Sorry, we wouldn't mount it on the nurse like I just pointed to. We would mount it on the front of the gurney because that's going to present to the reader first that's located next to the doors. And then that way, the individual pushing that gurney does not have to stop forward momentum. I know I said that before, but that's a very important concept. If they have to stop their forward momentum and wait for that door to open, it's pretty useless. In summation, this RFID assistive technology can be used for tagging gurneys or crash carts and getting them through doors more quickly and easily. The primary application for this is to tag wheelchairs, to allow the people that are in those wheelchairs to be able to access interior and exterior doors without the assistance of a staff member, and even call elevators without the assistance of a staff member. They can be mounted on walkers as well. So you see it'll work for a number of assistive applications. The bottom line is this. What we're attempting to do is we're attempting to make life easier, enhance the mobility and the freedom of movement for those that deserve it the most.